Now, as I say, we are finding the unknown inductors and capacitance value. So, resistor and inductor and capacitor. To know the capacitor value in a circuit, we are going to refer to Wein bridge method. So, this is also one of the method to find the value of a capacitor in a circuit. So for this also we are going to use a bridge circuit. So bridge circuit is like we are going to have resistance in one leg, resistance, and then resistance. So four legs are with resistance where we are having an input to the circuit. Okay. So general bridge circuit only. But here Wein bridge means you will get a capacitor in series, and at the same way you are going to have a capacitor in parallel. So here this is the variable resistance, and these are the two capacitors, one in series, one in parallel. So Wein bridge method means capacitors, the first one in series and the second one in parallel. You should remember this. So same thing, R1, R2, R3, R4, there is no change regarding this, and there will be a detector as well. Simple. Now this is C1 and this is C2. So usually what is the bridge technique? We are saying as R1 by R2 is equals to R3 by R4. You should remember that if you are having a resistance in the circuit, you are going to write it as R. Inductance in the circuit, you are going to write it as j omega L. Capacitance in the circuit, you are going to write it as 1 by j omega C or minus j by omega C. Anything is considerable. Okay. So remember, resistance in series with inductance, we wrote it as R plus j omega L. Resistance in series with capacitance, we can write it as R minus j by omega C. Remember, I considered this, not this. I just considered this. Same way, resistance is having parallel capacitance means, okay, parallel capacitance. Parallel capacitance means I am going to write it as R by 1 plus j omega CR. Okay, just write it as R by 1 plus j omega CR. Try to remember this. If you can't remember, just apply the concept like this. Resistor and capacitor means both are in parallel, means 1 by R equivalent is equals to 1 by R1 plus 1 by R2, isn't it? When two elements are in parallel, this is the formula we use. So this is equals to 1 by R1 means resistor, 1 by R2 means 1 by capacitor. Capacitor means what are we writing? 1 by j omega C, isn't it? So 1 by means it can go to numerator. So this will become as 1 by R plus j omega C. So try to understand this concept. When two elements are in parallel, this is the formula. So resistance means resistance only, but R2 means you have is capacitor. So 1 by j omega C, because resistor means capacitor means 1 by j omega C. I applied this here. 1 by j omega C. So it went to numerator. So this is the equation. Now I am going to take the LCM R. So this becomes 1 plus j omega CR. So 1 by R equivalent is equals to this one. Therefore, I can say R equivalent is equals to R by 1 plus j omega CR. So this is the parallel concept which you have learned already. By using the same concept, I got this equation. So that's the reason I straight away wrote this equation. If you can remember, it's well and good. If you can't, try to do this. This is very easy. Just one time practice, that's it. So you can easily remember. If you can remember, it's okay. If you can't, do the derivation. Matter of 1 second. But don't do something wrong. If you can't memorize, please do this in 1 minute. That's it. Okay. So now, what is R1? R1 means resistance in series with capacitance. That is the first leg, right? Resistance in series with capacitance means, I said consider R minus j omega c, because I considered this. For series I considered this. For parallel I have considered this, because for the flexibility of the derivation. So just blindly remember, don't go completely in depth. Okay, just blindly remember. So for series I am considering this. Okay, so what I am writing, R minus j by omega c by R2 is equals to R3. What is R3? R3 means again it is having parallel capacitor. Parallel capacitor means what I wrote? R by 1 plus j omega CR. So I write it as R by 1 plus j omega CR. R means R3, C means C3, right? Divided by R4. Okay? Numerator by denominator by denominator. Numerator by denominator by denominator. So I don't want all this complexities in my derivation. So what I am going to do is I am going to send R4 here, R2 this side. Sorry, this is R1. So this is omega C1. So I will write R4 this side. So how can I write? R4 into R1 minus j by omega C1 is equals to R2 is gone this side. R2 into R3 by 1 plus j omega C3 R3. So just remember, matter of practice. Clear? R4 is gone this side, R2 is gone this side. So now multiply this. It's better we multiply them. So this will become R1 R4 minus j R4 by omega C1, which is equals to R2 R3 by 1 plus j omega C3 R3. Here numerator by denominator, here only numerator. So let me make this one also, this side also as numerator by denominator. For that I am going to take LCM. So omega C1 is my LCM. So this one will become R1 R4 omega C1 minus j R4 is equals to R2 R3 by 1 plus j omega C3 R3. Now again I will send denominator this side and this denominator this side. So that one will become as 1 plus j omega C3 R3 into R1 R4 omega C1 minus j R4. This is gone this side. So this is the left side equation. Now the right side equation is, this is gone this side, is equals to omega C1 R2 R3. So right side equation is perfect, but left side we have again multiplication. So let us multiply this term with this term. Okay. So now what will be the equation? So for that what I am going to do, I am going to multiply these two. So 1 is multiplied with this. It will become as R1 R4 omega C1 minus j R4. So I multiplied 1 with this, 1 with this. So 1 is done. Now this element is left. This element first I am multiplying with this. So it will become j omega C3 R3 R1 R4 omega C1. Perfect. Then this one with this. Plus into minus. Minus j into j square. Remaining is omega C3 R3 R4, which is equals to omega C1 R2 R3. Okay, but usually according to mathematics we know that j square is equals to minus 1. So with this j square is minus 1. Minus 1 into minus will become plus. So I am going to write it as R1 R4 omega C1 minus j R4 plus j omega into omega square R1 R3 R4 C1 C3. Just I framed everything in line 1 3 4 1 3. Okay, that's the difference. So minus minus 1. Minus 1 into minus 1. Or just let me just write it as minus 1, not to confuse you. Okay. Omega C3 R3 R4 is equals to omega C1 R2 R3. Now this minus 1 into minus 1, sorry, minus into minus 1 will become plus 1, right? So now my equation is R1 R4 omega C1 minus J R4 plus J omega square, sorry, this is square, right? R1 R3 R4 C1 C3 plus, minus into minus plus, omega C3 R3 R4 is equals to omega C1 R2 R3. Now our right and left equations are in just addition and subtraction equation. Now I will say, let us equate the real part. So real part we are equating. So what is the real part? This is the real part because here there is no J. So I will write it as R1 R4 omega C1. Then this is J, this is J. Again here there is no J. So plus omega C3 R3 R4 is equals to, this side there is no J. So means omega C1 R2 R3. Omega, omega, omega. So in 3 values omega is there. So commonly I can eliminate them. Clear? So what did I do? I eliminated the omega values. Okay. So now when I eliminated this omega values, I am going to write the equation what we have. Okay. So now what is the equation we have? R1 R4 C1 plus R3 R4 C3 is equals to C1 R2 R3. C1 is here, C1 is here. So let me bring C1 this side and let me push C3 that side. So this will become R1 R4 C1 minus R2 R3 C1, which is equals to R3 R4 C3. So let me take C1 as common. So the equation is R1 R4 minus R2 R3, which is equals to R3 R4 C3. Clear? So now this is the equation. So now what I can do? I can send R3 R4 this side and C1 that side. Okay. R1 R4 minus R2 R3 divided by R3 R4 is equals to C3 by C1. So let me separate this. So R1 R4 by R3 R4 minus R2 R3 by R3 R4 is equals to C3 by C1. So here R3 R3 common, R4 R4 common. So finally I can say C3 by C1 is equals to R1 by R3 minus R2 by R4. Is it clear? So this way I have eliminated the equation. So finally I got C3 by C1. So in the exam, if C3 is questioned, you can send C1 that side. If C1 is questioned, you can send C3 that side. So you can use depending on your requirement. Okay. So when you equated real part, this is your equation. But you are still left with your imaginary part, isn't it? So let us equate the imaginary part. So when you equate imaginary part, what happens? So the imaginary part is this. This is real part. So this is imaginary. So minus JR4. Minus JR4. Then plus J omega square R1 R3 R4 C1 C3. So plus J omega square R1 R3 R4 C1 C3. R1 R3 R4 C1 C3. Then This is real part, this is real part. So on the right side, there is no real part. Sorry, there is no imaginary part. So I will say it as 0. So let me send this negative this side. So when I send negative this side, what happens? J omega square R1, R3, R4, C1, C3 is equals to JR4. So now the equation is omega square is equals to R4 by R1, R3, R4, C1, C3. So again here you have R4, R4. Therefore you can say omega square is equals to 1 by R1, R3, C1, C3. That's it. So this is your final answer. So these two you are supposed to remember for Wein bridge. So for Wein bridge you should remember this formulas for the problem solving. If it is derivation, you can easily derive, no worries. But for problem solving, you should remember these two. So just clearly see. Omega square means what? 1 by 1, 3, 1, 3. First leg and third leg. So R1, R3, C1, C3. Just remember this. R1, R3, C1, C3. Omega square is R1, R3, C1, C3. And here C3 by C1 is equals to 1 by 3 minus 2 by 4. Okay, R1 by R3 minus R2 by R4. 1 divided by third leg minus second leg divided by fourth leg. Like that, do something to remember the formula. Just blindly remember the formula, because during the problem solving, it's not easy for you to do these 2 pages of derivation. Because you see, you should derive this, then you should derive this, then only you will get this formula, then you should derive this, then only you will get this formula. So doing this much derivation can waste your time. So it's better you try to memorize the formula. Simple. Omega square is equals to first leg and third leg. In first leg you have R1 C1, third leg you have R3 C3. And here C3 by C1 is equals to R1 by R3 minus R2 by R4. So try to remember this formula. So this helps you to solve the problem. So next we will do a problem on Wein bridge. Clear?